So we established in the last video with the Nebular Hypothesis that something happened that got our big blob of dust spinning. Okay, so this is sort of a rough picture right here, but hopefully you get the idea. Let me just firm it up a little bit and draw it in a way that we can sort of work on a little bit more. So I'll say, all right, here's our dust right here. And it's maybe looks kind of spherical, maybe not. That sort of thing is just sort of sitting here. But now that it's spinning, of course, what's important about the spinning motion now is now it sort of has an axis. Because all things that spin have an axis like that. So whatever, I'll just sort of draw this, and I'll draw an arrow going like that, indicating the direction of the spin. And that spin was given to the dust by this object that passed or exploded or whatever it was, but it's spinning now. Okay, so a couple things. Spinning is a huge sort of catalyst for forming a solar system. I'm going to tell you why, because spinning has some really interesting consequences. Okay, so a couple of things that we still know is going on from our physics discussion. We still know that gravity is always, whether it's spinning or not, or even after it spins, was sort of unaffected by that thing that passed by. Gravity is always pulling things in. So we might expect that this object might start to sort of contract this way and this way and this way, because that's what gravity does. It always pulls it together. I mean, so maybe in some scenario, if just left alone under the gravity, then maybe like in a very long amount of time, maybe it would all condense down to something like this. I don't know. I'm just hypothesizing that, but that would be the effect of gravity, right? As this arrow keeps pulling down, this arrow keeps pulling up, this one keeps pulling over, and this one keeps pulling over here. This eventually might happen, but that's not really part of our story. The spin is very important, because what happens now is that once things are spinning, then I'm going to draw a different colored arrow on the dust ball now, maybe in, maybe blue like this, that there's going to be another outward force on these portions of the dust, and this is none other than that centrifugal force. Again, and this is the last time I'll do this. I want to bother people, but I'm going to put a little star next to it. It is not a real force, but that's all we need to know about it at the moment. And the centrifugal force is always an outwards force. Always wants to pull things away. And if you sort of don't remember this, you can go back and watch the video about how the moon formed. But I want to show you another video now that what someone did. I just found this on YouTube very fortuitously to explain what's going to happen to our dust ball now, because we have something new going on, right? We always had gravity, but now we're spinning, so we have this outward centrifugal force. So what someone did on YouTube is they took a water balloon, let's say, and put it in a table like this, and this table is allowed to spin. And they put the water balloon sort of in the table like this. So here's sort of the water balloon, and water balloons are all squishy and stretchy and stuff. So the issue then is what would happen if you put the water balloon sort of on a device like this that allowed the water balloon to spin about some axis like this. Okay, so take a look.